Hi बच्चों, welcome back to my channel and today we are going to be doing the solutions of the questions given in exercise 2.3, which is our chapter polynomial that we have been discussing, right? So let's dive right into it. The first question says, determine which of the following polynomials has x plus 1 as a factor. Now this question is about the direct application of factor theorem, and if you remember factor theorem, it said that if x plus a is a factor of any polynomial, then p of minus a will be equal to 0. If you remember, I told you in the previous video that factor theorem basically talks about the relationship between the factor and the zeros. So this is a factor, it says, right? So according to the factor theorem, if x plus 1 is a factor, then p of minus 1 should be equal to 0. And how are we deriving it? X plus 1 is a factor, so to find out the 0, we equate the factor with 0. So x is going to be minus 1, plus 1 is going to go this side, it will become minus 1, x is minus 1, right? So in this question, what we essentially have to do is apply the factor theorem for each of the following questions and find out p of minus 1. If p of minus 1 is equal to 0, then such a polynomial will have a factor of x plus 1. Let's look at the first one. It says x cube plus x square plus x plus 1. So p, this is, let's call it p of x, polynomial of variable x. So p of minus 1 should be minus 1 cube plus minus 1 square plus minus 1 plus 1. Minus 1 cube is minus 1 into minus 1 minus 1 into minus 1 into minus 1. So this will be 1 into minus 1, which is minus 1. So minus 1 plus minus 1 square is positive 1, plus into minus 1 is minus 1 plus 1. Plus 1 minus 1 cancels out, plus 1 minus 1 cancels out. Because p of minus 1 is equal to 0, therefore x plus 1 is a factor. Correct? Similarly, let's look at the next question. Again, we have to check whether x plus 1 is a factor of this. Again, similar, same as the first question, according to the factor theorem. Right? Let's find out p of minus 1. It should be minus 1 to the power 4 plus minus 1 to the power 3 plus minus 1 to the power 2 plus minus 1 plus 1. Minus 1 to the power 4 will be positive 1. Minus 1 to the power 3 will be negative 1. Minus 1 to the power 2 will be positive 1. Plus into minus 1 is minus 1 plus 1. Right? So it is 1 minus 1. I am opening the brackets here. Plus 1 minus 1 plus 1. Plus 1 minus 1 cancels out. Plus 1 minus 1 cancels out. So my p of minus 1 is equal to 1. Since p of minus 1 is not equal to 0, therefore, according to the factor theorem, x plus 1 is not a factor. Clear? Let's look at the next question, and we have to do all these questions the same way, right? Apply the factor theorem. P of x is equal to x to the power 4 plus 3x cube plus 3x square plus x plus 1. अभी हमें क्या करना है? Simply apply the factor theorem. According to the factor theorem, if x plus 1 is a factor, then p of minus 1 will be equal to 0. Now let's check. P of minus 1 is minus 1 to the power 4 plus 3 into minus 1 cube plus 3 into minus 1 square plus minus 1 plus 1. Fine? So we have minus 1 to the power 4, a negative number to the power of a positive, power of even numbers will give you a positive number. So it will be positive 1 or let me just write it as 1 plus 3 into negative 1. Minus 1 cube will be negative 1 plus 3 into 1 plus minus 1 plus 1. This is 1. 3 into negative 1 is minus 3 plus 3. This is minus 1 plus 1. Minus 3 plus 3 cancels out. Minus 1 plus 1 cancels out. P of minus 1 is equal to 1. Since P of minus 1 is not equal to 0, therefore, according to the factor theorem, x plus 1 is not a factor. Clear? Let's look at the next question. Again, we have to check whether P of minus 1 is equal to 0 or not. Let's find out. Minus 1 cube minus minus 1 square. We have to replace the x with minus 1 simply. Okay. 2, we have minus 2 plus root 2 times minus 1. Let me put this in a bracket. It is one term plus root 2. So minus 1 cube is going to give me minus 1 minus minus 1 square is going to give me positive 1 minus 2 into minus 1. 2 into minus 1 is going to give me minus 2, and root 2 into minus 1 is going to give me minus root 2. Correct? Plus root 2. So this is minus 1 minus 1. Now if I open the brackets, minus into minus is plus, so it's positive 2, positive root 2, positive root 2. This is minus 2 plus 2 plus 2 root 2. Root 2 plus root 2 will be 2 root 2. This cancels out. So P of minus 1 is equal to 2 root 2. Since P of minus 1 is not equal to 0, therefore x plus 1 is not a factor. Clear? Now let's come to the second question. The second question says, using the factor theorem, use the factor theorem to determine whether g of x is a factor of p of x. In the last video also I had told you, whenever you have to apply the factor theorem, if the factor is given, you find out the 0 and then solve the question. If the 0 of the polynomial is given, you find out the factor and then solve the question. In this question, the factor is given to you, right? So from here we are going to find out the possible 0 of this polynomial, and if the 0 fits, then that means this will be a factor. If the 0 doesn't fit, that means it will not be a factor. If x plus 1 is a factor, then P of minus 1 should be equal to 0, correct? So let's look at P of minus 1. P of minus 1 is 2 times minus 1 cube plus minus 1 square minus 2 times minus 1 minus 1, right? So this gives me 2 multiplied by minus 1. Minus 1 cube is minus 1 plus 1 square is 1 minus 2 into minus 1 is minus 2 minus 1. 2 into minus 1 is minus 2 plus 1 plus minus into minus 2 is plus 2 minus 1, right? So minus 2 plus 2 cancels out, plus 1 minus 1 cancels out. P of minus 1 is equal to 0. Therefore, g of x is a factor of P of x. And the rest of the questions also we are going to solve it the same way. Let's look at the next question. Same, apply the factor theorem. If x plus 2 is a factor, then P of minus 2 should be equal to 0. How am I finding out? Equate the factor with 0. You will find out the possible value of 0 of that polynomial. Let's look for P of minus 2. It's minus 2 cube plus 3 into minus 2 square plus 3 into minus 2 plus 1. Minus 2 cube is minus 8 plus 3 into minus 2 square is 4 plus 3 into minus 2 is minus 6 plus 1, which is minus 8 plus 12 minus 6 plus 1. Minus 8 plus 12 is 4 minus 6 plus 1, right? 4 minus 6 is minus 2 plus 1, which is equal to minus 1, right? Since p of minus 2 is not equal to 0, therefore x plus 2 is not a factor. And how am I saying it? As per the factor theorem. Clear? Let's look at the next question. Now we have to see whether this is a factor of this. For this to be a factor, 0 will be x minus 3 is equal to 0, so x is equal to 3. So p of 3 should be equal to 0. Let's check. P of 3 is 3q minus 4 times 3 square plus 3 plus 6. 3 cube is 3 3s are 9, 9 3s are 27 minus 4 times 3 3s are 9 plus 3 plus 6, which is equal to 27 minus 9 4s are 36 plus 6 plus 3 is 9, right? So 27 minus 36 is minus 9 plus 9. So p of 3 is equal to 0. Because p of 3 is equal to 0, therefore x minus 3 is a factor of p of x. Clear how these questions are to be solved? If there is a doubt about how am I deriving the 0 from the factor, please do check out my earlier video which I have uploaded on the factor theorem, and it will be very clear to you. Okay guys? Okay bachcho? Now let's look at the third question. Very interesting question. Generally we find these kind of questions in the paper. What it says is, there is a missing value in my polynomial, and it is stated as k, and it says find the value of this k if x plus 1 is a factor of this polynomial. If x plus 1 is a factor of each of the polynomial, now again we have to apply the factor theorem. According to the factor theorem, if x minus 1 is a factor, then p of 1 should be equal to 0. How to find out? x minus 1 को 0 से equate करो, x की value 1 आएगी, that means p of 1 should be equal to 0. That means अगर x की value 1 है तो 1 is the 0 of the polynomial. Correct? अब p of 1 को 0 से equate करो, आपको k की वैल्यू मिल जाएगी. p of 1 will be equal to 1 square plus 1 plus k, and this has to be equal to 0. Why? Because 1 is the 0 of the polynomial. Correct? We know 1 is the 0 of the polynomial. Why? Because the question says x minus 1 is the factor, and as per the factor theorem, if the factor is given, you can always find out the 0 applying the theorem. So this is 1 plus 1 plus k is equal to 0, 2 plus k is equal to 0, so k is equal to minus 2, right? A very easy question, right? And these kinds of questions are generally asked, bachche. Again, same thing. Let me. Again, if x minus 1 is to be a factor, right, then p of 1 should be equal to 0. Let's equate again. P of 1 is 2 times 1 square plus k times 1 plus root 2, and this has to be equal to 0. 2 times 1 square is 2 plus k times 1 is k plus root 2 is equal to 0. So k is equal to minus 2 minus root 2. This is the value of k, right? Let's look at the next question. सेम लॉजिक है, हमें अप्लाई करना है. factor theorem. According to factor theorem, if x minus 1 is a factor, then p of 1 will be equal to 0. Let's find out p of 1. It is k times 1 square minus root 2 times 1 plus 1. K times 1 square is k, minus root 2 times 1 is root 2 plus 1, which should be equal to 0 because 1 is the 0 of the polynomial. So k will be root 2 minus 1. This is the value of k. Clear? Let's look at another question. The reasoning will be the same, but the reason I'm copying this reasoning again and again, bacho, is because whenever you're solving this question, you have to specify that if the factor is given, you are applying the factor theorem and you're finding out the 0. So you have to mention this reasoning. Okay, there is a mark for this reasoning in your exams. Let's find out. P of 1 will be k times 1 square minus 3 times 1 plus k, which is k times 1 is k, minus 3 times 1 is 3 plus k, which is equal to 0. So k plus k is, let's bring the k's together. 2k minus 3 is equal to 0, 2k is equal to positive 3, and k is equal to 3 upon 2. This is the value. I hope this is clear. Okay, so that is all. The remaining questions, which I believe is question 4 and question 5, we are going to take up in the next video. I hope whatever we discussed so far, the application of the factor theorem and all of that was very clear to you. And if there's any doubt about what do you mean by the factor theorem, please do watch out my video, which I have already uploaded, and you'll find the link in the description below. Alright bacho, thank you very much and keep learning, and I'll see you in the next video very soon.